This video will focus on the properties of waves. A wave is a means of transferring energy and information from one point to another. Importantly, there is no transfer of matter between the 2 points. Transverse waves are waves where the direction of vibrations is at 90 degrees to the direction in which the wave travels. An example is water waves. Longitudinal waves are waves where the vibrations of the particles are along the direction in which the wave travels. Sound waves are an example of this type of wave. The first property we will look at is amplitude, represented by A. Amplitude is the maximum movement of particles from their rest position. It is the height of a crest, or the depth of a trough. Next is wavelength, represented by the Greek letter lambda. Wavelength is the distance between one wave peak and the next wave peak along the path of a wave, and is measured in meters. It is also the distance between the bottom of one trough to the next. Frequency, represented by F, is the number of wave peaks that pass a point in 1 second. It is measured in hertz, or Hz. 1 hertz is equal to 1 peak per second. Time period, represented by T, is the time taken for a source to produce one wave. The time period is equal to 1 divided by the frequency, and the frequency is equal to 1 divided by the time period. To calculate the frequency of a wave with a time period of 8.0 seconds, we use the formula frequency equals 1 divided by time period. Dividing 1 by 8 gives a frequency of 0.125 Hertz. To find the time period of a wave with a frequency of 50 Hertz, we use the formula T equals 1 divided by F. Dividing 1 by 50 gives a time period of 0.020 seconds. The wave equation is speed equals frequency times wavelength, or V equals F times lambda. Speed is measured in meters per second, wavelength in meters, and frequency in hertz. This equation can be rearranged to find frequency or wavelength. Let's calculate the speed of a water wave with a wavelength of 3 meters and a frequency of 6 hertz. Using the wave equation V equals F times lambda, we multiply 6 hertz by 3 meters. The speed of the wave is 18 meters per second. For our next question, we calculate the frequency of a wave in water with a wavelength of 2.0 meters if its speed is 16 meters per second. Rearranging the wave equation gives us frequency equals speed divided by wavelength. Dividing 16 meters per second by 2 meters gives a frequency of 8 hertz. Question 3 asks us to calculate the wavelength of a sound wave in water with a frequency of 300 hertz if its speed is 1,500 meters per second. Using the wave equation, we rearrange it to find wavelength, lambda, which equals speed divided by frequency. Dividing 1,500 meters per second by 300 hertz gives a wavelength of 5 meters. Question 4 asks us to calculate the speed of a wave that has a wavelength of 30 meters and a time period of 0.04 seconds. First, calculate the frequency by dividing 1 by the time period, which is 25 hertz. Then, use the wave equation to find speed. 25 hertz multiplied by 30 meters equals 750 meters per second.